So we are solving one-step inequalities. There is one golden rule that you need to remember for all inequalities. Does anybody know what it is? Have you ever solved an inequality before? Let me show you what one even looks like. So you're going to be solving things like x plus 2 is less than 10. Stuff like that. Yeah. Well, that's true. You are absolutely right about that. Well, no. In fact, they're not going to be equal because these are inequalities. So you're going to solve them the exact same way that you would if it was an equal sign. So normally, wouldn't you just subtract 2 from both sides? Yeah. So I'm going to do the same things that I always do. That's what I mean when I say you guys already know how to do this stuff. If you can solve an equation, you can solve an inequality. But there is one thing that we need to be aware of at all times. And here it is. Well, let's solve this one first, and then I'll tell you. So I'm going to minus 2, just like I always do. But instead of bringing down an equal sign, I just bring down the same inequality symbol. 10 minus 2 gets me an 8. Okay? I can graph this just like we did on the Fast 5. So if I want to graph this answer, right, I could just give myself a number line. Here's an 8, here's a 7, here's a 9. What kind of a dot would I put at 8? An open circle at 8. I like to do mine a little bit above the line, just so, because if you put it on the line, like I said before, some of you make it too small and then you can't tell if it's open or closed or not. So that's just my preference. You can put it right on the line if you want. And then x is less than 8, so which way should I be shading? To the left, right? This arrow's pointing to the left. I'm going to go to the left. So there's my graph of that answer. Okay. So now let's put down the golden rule of inequalities. So big old star for this important fact. If you multiply or divide by a negative, does anybody know what happens? It depends on the number, but something happens to the symbol. Does anybody know what you do with the symbol?
Change.
Kind of. You got to flip it over. If you multiply or divide by a negative, you must flip the inequality symbol. Over. So in this example, that didn't happen. I didn't multiply or divide by a negative, so I didn't have to worry about it. But if I do, I'm going to need to flip it. So let's do an example that involves flipping. Okay, so we'll start off with something nice and easy. Let's say I had negative 3 is less than or equal to, you know, I kind of messed that up. Scratch that. Sorry. I meant to do negative 18 is less than or equal to negative 3. X. So I'm going to start off how I normally start off, right? If that was an equal sign, how would you get the x by itself? I'd divide both sides by negative 3. Once I realize in my brain, oh, I'm about to divide by a negative. Anytime you divide or multiply by a negative, that you need a little red flag going off in your brain, because that means, oh, I have to flip that symbol over. So watch how this works. I'm going to divide both sides by negative 3, just like I always do. Negative 18 divided by negative 3 is now positive 6, right? But that symbol now gets flipped over, and it's going to go this way now. And then I just have the x on this side. Super important, and I only ever do this when I multiply or divide both sides by a negative number. Okay, so otherwise I do everything like I always do. I just solve all day long, nice and easy. But if I happen to be multiplying or dividing both sides by a negative, I gotta flip. So let's go ahead and graph this answer. What kind of a dot is going to go at the 6? Closed in this case, right? And then, be careful now. Which way are you shading? Well, it's one of the two. Well, remember, if the variable is not first, I highly recommend that you rewrite it. Flop it over. X is less than or equal to 6. Right? They mean the exact same thing. I just flopped it over. Pac-Man was eating the 6 here. Pac-Man is still eating the 6, so I haven't changed anything. But this is so much easier to graph. I want the numbers less than or equal to 6. So that happens to the left, right? And the arrow is going to tell me which way to go as long as I have the variable first. So I should be shading this way. Don't forget, you can check this answer, right? You can take 5 and plug it back in and see if it actually works. So if I took 5 and I plugged it back into my original, negative 3 times 5 is now negative 15. Is negative 18 less than or equal to negative 15? Yes, because remember, in negative land, the further you go this way, the further negative you go, the smaller the numbers get. So negative 18 is smaller than negative 15. Does this make sense? Okay. So let me have you... What would I do with one like this? I know. So, if you're going to solve for x, what is it that you're going to do? Pablo? So you can, but you're doing a little bit more work than you have to. So I want to get x by itself, right?
Wait, wouldn't you multiply both sides by 4?
Exactly. I'm going to multiply both sides by 4. Let me ask you. This is a negative 2, so do I flip that symbol over when I do that? Remember what it says. It says, if you multiply or divide by a negative, you must flip the inequality symbol over. So when I go to do this problem, I'm going to multiply both sides by 4. 4 is not negative. So I'm not going to flip my symbol over. The only time, right, so I'm going to multiply both sides by 4, times u by 4, times u by 4. I'm multiplying by 4, not negative 4. It doesn't matter if this number is positive or negative. It matters the number I'm multiplying by. So in this case it's positive, so I leave it alone. So on the left-hand side I get x. That's going to stay. That symbol stays exactly as it is. Negative 2 times 4 is now a negative 8. Does that make sense? So be careful. Just because there's negative numbers in your problem doesn't automatically mean that you're flipping that symbol over. It's only when I'm multiplying or dividing by that negative number things change. Okay? Go ahead and graph this for me if you haven't already. Think about your dots. Should they be open? Should they be closed? Which way am I shading? Oh. Should my dot be open or closed? Open. And I should shade to the right. That variable's first, so that tells me which way to go. Let's make things a little bit more interesting, shall we? Thought you'd never ask. Okay. How about... what if we try a little word problem? Let's try that. A word problem with inequalities? What? Okay. Let's try this. How about... 3 times a number is less than 15. One thing about some parts of math that I don't like is how much overlap there is in the words that we use. So less than here means different than less than when we were doing subtraction. Like 5 less than a number means subtraction. But the way this is phrased means the inequality symbol less than. I wish we had different words for them. You have an inequality?
Yeah.
All right, what am I going to write?
3x less than 15.
Like that? I totally agree. Did you write the same thing? 3 times a number, so that's 3 times x, or n, or whatever number variable you chose to use, is less than 15. So I have the is less than symbol, 15. Now that we have it written as an inequality, we can go ahead and solve. All I have to do to get x by itself is divide by 3. Do I need to flip the inequality symbol? No, I didn't do anything with a negative, so I don't have to worry about it. 15 divided by 3 gets me a 5. And then if I asked you to graph that, you could? Okay, go ahead. Graph it if you haven't already. Oh, I'm ready. Thank you so much. Is this thank you? Thank you, guys.
You're welcome.
Okay, what kind of a dot goes at 5?
Open dot.
Open. Is Pablo the only one here today?
Yeah.
Besides me and my cool notebook? Oh my gosh. Open dot at 5 and I shade which way? What? You want a face on the notebook? Oh my gosh. It has everything you could possibly want. Yes. There's an apple right there. Look. You may not be able to see it. Oh, there's an apple right there. There's all the symbols that it's all these symbols. I'll show you. See? So you go on the app, so I go on the app, and for each symbol, I set where I want the notes to be sent. I can send it to as an email, I could text it, I could do whatever I wanted. So I just set up wherever I want it to be. So when I check off this box, yours will go right to the Google thing for this class that I made. So I better check that off so it knows. All right, let's try another word problem. Let's make it harder. How about, ooh, that's a good one. I'm going to try and keep it to one page today. Let's do the difference of x and 20 is greater than 100. So see if you can write that inequality and then solve it. Think back to what operation difference is. Go ahead.
X minus 20 greater than 100.
What do you guys think? I agree. It's perfect. The difference of x and 20, difference is subtraction. With that wording, it just means the first number minus the second number. So x minus 20. Because remember there was all those where the subtraction you had to like flip it around. Maybe we'll try a tricky one like that. So anyway, now if I'm going to solve this, what do I do? Add the 20 to both sides. X is greater than 120. And then I can graph it if I want to graph it. What kind of a dot at 120? Open, shaded to the
Right.
right. All the x's greater than 120, there they are. Okay, one more. Let's do one that has a fraction in it. So let's try, 3/10 of a number is less than 50. Excuse me, 3/10 of a number is less than 50. Actually, I guess you could do this without doing a fraction. Because you can write 3/10 as a decimal or as a fraction, right? Either one.
Got it.
So what'd you write?
3/10.
As what? A fraction or a decimal?
Fraction.
As a fraction? Okay. So if you do a fraction, 3/10, and then of a number, what does that mean to do?
X.
Yeah, it's just times. 3/10 of a number is just 3/10 times x. Is less than 50. So less than 50, right? Okay. Now the question is, how do you solve this?
Multiply 30 by 10.
So you can do that. You can clear the fractions. Just like when you have an equation and we clear the fractions, you can do it with an inequality. So I love that idea. So multiply everything by 10 to start off with. You could totally do that. Remember how to do it. You divide down, multiply up. So that would just get me 3x is less than 10 times 50 gets me 500, right? And then all I have to do is divide by that 3, right? So x would be less than 500 over 3. Not bad. Okay, we ready to try some?
Yes.
All right, so let's stop this.